Chemistry problems would be much easier if every reaction had only one reactant. But the truth is, most chemical reactions have more than one reactant, and that's why we have to talk about the subject for this video, defining limiting reactants. Our learning goals in this case are going to be defining what a limiting reactant is and how it affects the outcome of a reaction. So let's consider the following scenario. I've got 0.467 moles of aluminum oxide, and I've got 1.19 moles of sodium hydroxide, and I'm going to mix these two together to make some aluminum sodium dioxide, NaAlO2. Now, I've got two reactants now, and I'm given amounts of both of those. I can't necessarily assume that they are exactly the right amounts that are needed to seamlessly be used up all together in one reaction. So what I'll need to do is figure out, using this balanced chemical equation for this process, I'll need to figure out how much I could possibly get from each of these two amounts of starting materials. So what we're looking at is a moles to moles conversion. I'm starting with moles of each of my reactants, and I want to know how much is produced. We'll just say that means moles. So now if I plug this in for aluminum oxide, I start off with 0.467. That's what I have. What I want is moles of aluminum sodium dioxide, and the mole ratio coming from the balanced chemical equation is 2 moles of NaAlO2 for every 1 mole of Al2O3, so my mole ratio is 2 to 1, so I should produce 0.934 moles of the product. What about if I had 1.19 moles of sodium hydroxide? Well, that would imply that I would start with 1.19 moles of sodium hydroxide. The mole ratio in this case is 2 to 2. Each of those species has a 2 in front of it in the balanced chemical equation. So now I should be producing 1.19 moles of sodium aluminum dioxide. So which result is correct? Now, you're probably way ahead of me, and you figured out that I can't make more in one case than I can in the other. I'm going to be limited probably by the one that makes the least. But let's see if we can understand a little better why that is. I'm going to use an analogy to explain this. I like to eat omelets, and fortunately my wife is really good at making them, so I'm going to say that each omelet that we eat and make has 3 eggs. It uses a teaspoon of butter, it has a slice of ham, and a 1/4 cup of shredded cheese. That's what makes the ideal omelet in our household. Now we're ready to make some omelets. We go to the fridge and we find that what we have available are 2 dozen eggs, so lots of eggs. We've got a stick of butter, we've got a package with 10 slices of ham, and we've got about 3 cups of shredded cheese that we can put in here. So now the dilemma is, how many omelets can we make? Can we invite somebody over to eat breakfast with us to eat these omelets? So I've got to go down and I've got to figure out for each one of these ingredients how many omelets can it make, and then from that amount I can decide which one sort of limits how many total omelets we can make. So with 2 dozen eggs, I've got 24 eggs. I need 3 for each omelet, so 3 divided into 24 gives me 8 omelets. I can make 8 omelets with this number of eggs. With a stick of butter, that's equal to 12 teaspoons, so 1 teaspoon of butter is needed for an omelet, so that means I can make 12 omelets with the butter. With the ham, 10 slices, 1 slice per omelet, I can make 10 omelets. The shredded cheese is a little harder, but if a 1/4 cup of shredded cheese is needed for every omelet, then I can make 4 omelets with 1 cup, and if I've got 3 cups, I can make 12 omelets. So this is the total number of omelets I could make with each of these ingredients available, and I hope it's obvious that the limiting ingredient in this case is the eggs. I can only make 8 omelets with the eggs. I can make more than that with each of the others. Now, when I go to survey what's left over, I would find that I have no eggs left over if I've made 8 omelets. I've got about 4 teaspoons of butter left over. I've got 2 slices of ham, and I've got 1 cup of cheese left over. So the bottom line here is that the thing that was limiting how many omelets I could make was the thing that ran out first. And that is true in chemistry also. The limiting ingredient is always the first one that's used up completely, so that there's none left over. All the other ones, there's something left over. So let's see how this translates to chemical reactions. Chemical reactions are like omelets. So the limiting reactant is going to be the first reactant that's used up completely. So we've already determined that when we've created 0.934 moles of the product, we've used up the aluminum oxide. It's all gone, and we can't get to 1.19 moles. That was the amount that we would have gotten from the sodium hydroxide. So this tells us that the aluminum oxide is the limiting reactant. Since there is some sodium hydroxide left over, this is what we call an excess reactant. So the whole point of this is to get you familiar with the idea of a limiting reactant and excess reactant. Could be more than one. We're going to be dealing with this a little bit more in more depth in the next video.